Hello, welcome back to this course on Python for data analysis. And today's class will talk about introduction to control flows in Python. So what are control flows? Control flows is a fundamental concept in programming that allows you to dictate the order in which statements are executed based on specific condition and loops. In Python, control flow structures such as if statement, your else if statement, your while statement, and your for loop provides the necessary tools to make your program more dynamic and responsive. So we are going to learn how to use the if statement, the else statement, and the else if statement. To use the if statement and the else statement and the else if statement in Python, you need to understand logical operators, which we have gone through in the previous class. So the logical operators we have are we have your equal operator, your not equal operator, your less than operator, your less than or equal to operator, your greater than or equal to operator, and your greater than operator. These operators can be used in several ways and commonly in if-else statements and if statements, but it can also be used in loops and while loops, right? It's used in while loops. So to get started with our if statement, first you have to have two variables that you are going to compare together. You have your A, which is 33, and my B, which is 200. I said if B is greater than A, give us this particular value. And what I want you to notice here is my if statement and the value that's going to be printed out are in an indentation. If you notice this right here, you see an indentation over here. This simply means that this particular value is inside of this if statement, meaning this value is nested inside of this if statement and this value is blocked into this if statement. So in the scenario where this is not longer true, I would not get any values printed out, okay? So let's test this out. We run this and we get our if statement because B is greater than A. Then when I switch this up and make this to be 300, I run this again and I get nothing because this statement no longer is seen by my Python interpreter because B is actually less than A. You understand? So Python relies on indentation, white space at the beginning of a line to identify scope in the code. Other programming languages such as JavaScript, Java, they use curly brackets or curly braces for this purpose. So the next concept you need to understand when it comes to control flow is your else if statement. The else if statement in Python is a way to tell Python that we have a condition, which is the if condition, and we also have another condition that will be tested if the first condition is not true. Okay, so we have this condition. Say is A is equals to 3, B is equals to 3, and whereas if B is greater than 30, is greater than A, give us this. Then say else if A is equals to B, give us this. From a logical standpoint, you see that B is equals to A. So this is not going to run and this is going to run. So let's run it and see. So we got our answer correctly, which is B is A and B are equal values. So the next concept we need to understand is our else statement. The else statement washes, right? It washes to see if all of our conditions are false, then it runs regardless. Simply means is a fallback keyword, right? It washes to look if all the statements are not correct, then it runs regardless of anything that happens. So if this is false, it runs this else if statement. If this is false, then it runs this regardless of any other thing that is in this condition. But once this is true, it stops here and moves over to the next line. Let me just add the next line. Let's say print, I am the final line. I am the honored one. Okay, so when I run this, I get A is greater than B. Then this comes next. After it jumps all the way from here, then it jumps all the way to here without looking at this or this. Okay, so that is the beauty of a control flow. I get to control the flow in which my code is executed. You can always also have an else statement without an else if. Your if statement, then your else statement. But you cannot have an else statement without your if statement to open it up. Okay. So, so There is a shorter way of writing your else statement. You can actually put all your statements in one line like this. Instead of having it like this, you can basically just have it like this and it will still give you the same result. Similarly, for your else if statement, you can have this is the condition that runs if this is true, then your else statement runs if the other one is not true. Okay, so we got print B because this A is not greater than B, so this is what we got. So this particular technique is known as the ternary operator, and in JavaScript and in other programming language, it's executed in a different way. Okay, so just focus on this one. This value particularly might not be the best scenario to test this in. So let's just remove this from our sample set and just move on. So like in any operator, you can combine your logical statements together. I can have this and this combined into one logical statement. Right? I can have as many combinations as I want to. But remember, when we combine two logical operations together and we are using the AND combinator, we have to make sure that both of them are true for this particular if statement to run. Okay, so let's look at this. Is A greater than B? Obviously, A is greater than B. Then we check. Is C greater than A? C is also greater than A. So this will return true. But in a scenario where C is no longer greater than A, we will get nothing. Nothing is going to be run and nothing is going to come out. Okay. So moving on to the next statement, which is our OR operator. What this does is basically what it does when we looked at operator. It combines both operations, and if either of them are true, it will run. If both of them are false, it will not run. If both of them are true, it will also run. So you just need one true to become valid. As you can see, it ran successfully and we are good. So the next operation we will look at is the NOT operator. What it basically does is it negates whatever this logical operator gives us. So look at this statement. We have is A greater than B, A is not greater than B. And remember, our if statement only works when this is true. So let me show you something. If I put false, yeah, this is still a valid statement because this will always be false and this will never run, right? So this will be true. If I put true, similarly, this will always be true and this will always run. So what I want you to understand here is that this if statement doesn't really care if there's a not or it's a true, whatever. You just make sure that the condition at the end of the day results to true. Okay? So once this is true, this will have to run. So let's look at this. A is not greater than B, so this will be false, right? So ideally, without this not statement, this would have not run. But when I had this not statement, it simply changes the value from true to false. If it was a false value that we got from here, to switch it to true. If it was a true value, you switch it to false. So let's run this, and we got our answer here. If I were to remove this and run this without the not statement, I will get nothing. Okay? Now moving on. We can also nest our loops. We can go as deep as we want to or as shallow as we want to. Okay? So we have our if statement. We said if x is greater than 10, we get above 10. Then we have another loop, another condition that if this x now is also greater than 20, we should print this. If x is not greater than 20, we should get this. So we are going to print in two values, but basically it will check if x is also greater than 20. So run this. Ideally, what we are going to get will be, but not above 20. Right? We get above 10, but not above 20. But if this is less than 10, let's put 6 here. We are not going to get anything because it's not even going to enter this loop. So let's make this 60, and we are going to enter this first loop. Check. Okay. Got our value above 10. Then we also check it's also above 20. So we got our answer. So let's make this something else. Let's say 12. We got our answer as well, which is the correct statement. So there are situations when you are writing your if statement that you know that you want to test a condition, but you don't know what you are actually testing for or what you are going to get out when you test it. So in situations such as that, you have to put in your pass keyword there. to act as a placeholder for your logic or your statement that's going to be in your if condition. And this works for all blocked data structures. That's your if, your while loop, your for loop, your functions, and so on and so forth. So let's run this. We are going to run and need to be successful. Imagine I left this like this. We are going to have an issue, which is incomplete input, meaning this was expecting something to be here, but it got nothing. Right? So you have to put in your pass to make sure it's valid and you can move on. And when you have the knowledge to do, or you remember what you're supposed to do, you can just add your value here. Okay. So the next control flow we have are your while loops. You have your loops, right? In your loops, we have two types of loops, which are your while loops and your for loop. Okay, the while loop allows you to execute a code as long as a condition is true. Right? It allows you to keep doing a particular operation over and over again as long as the condition is true. Look at this flow chart. So this is a condition. This is the action or the statement that is going to be executed. So it's first thing, it checks the condition. Is this condition true? Yes, it is true. It does the particular work or it executes that particular code. Then it goes again and checks, is this condition still true? Does it until this condition becomes false. Then it stops running, okay, and breaks out of that loop. So this scenario, if you create a condition that will never be false, your loop will keep going until your machine goes off or it runs out of RAM and storage, okay? So let's have an example here. So in this condition, we have if, say, I is equals to 1, okay? And we say I is less than 6, we want to print out the value of I. Then, but if we were to leave this without adding this increment function here, this loop will keep going until my system goes off or I turn off this particular kernel, right? This particular operation. So say, let me just give you an example of what I mean. Let's just leave this and run this, okay? So this. You see, it keeps adding 1 until my laptop goes off. But what I can do here is to just restart my kernel, okay? Let's see if I can restart this. Restart, and it will stop running. As you can see, it almost make my laptop to become slow, okay? Made my laptop to become extremely slow, okay? If you notice, my laptop became extremely slow just now because of what I just did. Okay, is equals to I, let's just do this, plus equal to 1, okay? Now let's run this. So we are going to count from, okay, it's going to check, is I less than 6, okay? When I is 1, I is less than 6, so print 1, then go again, add 1, 2, 3, 4, 5. Then it checks for the last time, is 6 less than 6? 6 is greater than 6 or is equal to 6, but it's not less than 6. So it's going to look at that and say, okay, this is no longer true. This condition is no longer true. So exit and stop running this loop. So it's going to see it here and break from it. But like I said, remember to add your increment or add an action or your increment value that stops your loop, right? Or lets your loop go forever, which I did and my laptop always went off. So please add your condition. So the next thing you need to know when you're working with loop is your break statement. Your break statement allows you to end a loop prematurely, right? Once a condition is met. Okay?
Sorry.
What is that? Come out and use a broom now. Okane Wasaki. Watashi wa star.
You cut again.
No, I go cut where we talk. Okane Wasaki. What is machine they did? You test now. Mr. Tire. You patrol now. You deliver for them. For who? Make I look the way
Continue your work now, bro.
Make I look at the tire, bro. Oh, see sharp time. Sabi the work.
Don't mean anything, no, guys.
Sabi the work. Sabi the work.
You just mock me, guys. Enjoy, have fun.
My blower. My blows on.
You will continue your work.
My blues. Carry it, go. You see the work up and down now. Finish 50 the worker. Make I continue. Wakane, Wasaki, Watashi wa stuff. Wakane, Wasaki.
You not seen mushroom for here before?
No, this is the first time. I think because of the water and the wood.
Water the entire year. Water is still on top of the sink.
See how this so.
Enjoy your continue.
So the next thing we need to understand is the break statement. So the break statement allows you to break out of a loop or to discontinue a loop once a condition becomes true. Okay. So look at this condition now. We have our initializer. We have our condition here. Then we have our print statement. So we have a condition here that once it becomes true, we will stop the counting of this loop. So this loop goes, okay, it counts 1, it prints, it has 2, 3. So once you get to 3, it will immediately stop, and we will not print above 3. So let's run this. So we have 1, 2, 3. Okay. Originally, it's supposed to go beyond this and get to 5. But now, since we have this loop here, it will stop counting. Okay. So in this scenario, we have a continuous statement. So what the continuous statement does is just like jumping over a particular value. It doesn't stop, right? It doesn't break the loop. It just jumps over that particular value once the condition is true. So in this scenario, we have our initializer, our condition. So the first thing we did, we switched our code logic in order to see the effect of this really well. The first thing we did was we added 1 to our initializer, which is 1 plus 0 plus 1, which is 1. So if the I now, which is 1, is equal to 3, it should continue. If not, it should just print it out. So we have 1, 2. When it gets to 3, it will skip 3, then jump and start from 4, 5. So let's go. Okay, 4, 5, 6. The reason we are getting 6 is basically this. It prints out before it adds, you understand? So it will move to 6. Like we'll first add 6, then it prints out before it checks if 6 was actually a value. That's why we are actually getting 6 here as well. Okay. So you can also add your else statement to your while loop, what it simply does is anytime you run the while loop, once it's completed, you just add this to your while loop, which is like once this condition becomes false, it will simply just add this statement or whatever you put here. Maybe you want a condition that, like if you're building a game, one that once the player's health is drained out, a pop-up should come up. So those kinds of things you put inside the else statement, which once the health of the player is drained out and your while loop for that game stops, a particular screen will pop up for you to say, okay, game over. So this is basically how you use your while loop. Very easy and straight to the point. Then the next loop we have is your for loop. The for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. So the for loop is used when you are iterating over a sequence. That means things that have or that has a set amount of data, right? A set length of data. So you know the length that you are going to iterate over. It's not an unlimited amount of data that only stores when a condition is met. So there's the logic I like to use when it comes to loop and while loop and for loop is a staircase. Say you have a staircase, let's say it's 1,000 step long, right? And you're asked to walk over that staircase. So in a while loop, you have a condition for you to keep walking. So you say the action will be keep walking over the staircase, right? As long as the weather is sunny. Once the weather changes condition to maybe rainy, you stop, right? So that is your for loop. So you keep doing a particular action until a condition is met. So even if you get to the top of the staircase and the weather is still sunny and you did not set a condition to stop trying to climb the step, you will keep walking and maybe fall off the cliff or whatever is there. So that is for your while loop. Then for for loop, the way it works is it knows the numbers of steps, right? So you keep walking over them 1, 2, 3, 4, 5 until you get to the end. Then you simply stop. So you keep looping until you get to the end. But for your while loop, you just keep looping until a condition that you set for yourself is met. And the condition can also be the length of the stairs and all of that. So that's the logic or the analogy I use um, to relate this to real world applications. Okay. So a for loop is used for iterable sequence. So to use a for loop, you simply have to know the keyword, which is you put in the for, right? The item you want, each of the item, then the list or the sequence that you want to get those items for. So what it moves, it walks over each of the items. So when you start, say for a particular, let's use this example, for fruit inside this fruit list, you walk over it. So the first one will be apple, banana, and cherry. So let's walk over this and we'll get our answer. So apple, banana, and cherry. So a for loop does not need you to know the index, right? So you need to know the index, but you can actually get that. Let's see, x comma I. Let's see if this works. I think this should. Well, let's see if I can get this. One of Virginia. Akane Wasaki Watashimashita. Okay, so for your for loop, you can loop over each of the item and it goes to each of the item and print those items out. So you specified, okay, go over each of the item and print those items. So you have your apple, banana, and cherry. So you can also loop over a string because strings are basically characters joined together as individual items. So when I loop over this, I'll get BANANA, right? So the break statement works similarly as it does with the while loop. It goes into this, print the first one, then check if it's banana. If it's not, it will go to the next one and go repeat this loop until we get this if statement where it's equals to banana, and then we'll stop. We're going to get apple and banana. The reason it's printing banana here is because it will first print before it checks, so you can't really jump that step. Okay, so we have the break statement here. So anything that comes after the break, just to show you that anything that comes after the break will not be printed. Okay, normally we're supposed to print x, but it's not printed. We just switched up the statement, and that's how we also get apple here. So your continue statement works similarly as it does with while loop. It goes over to that continue statement, looks at it, then jump over that particular statement. So let's do that. And you see we got apple, then we skip banana and got cherry. Okay. So the range function allows you to create a list of numbers starting from 0 to the end number. So we have to loop over a set of code at a specific number of times. We can use the range function. So if we want to do a particular function a couple number of times, but we don't have a list to actually loop over, we just know we want a particular value printed out for a particular number of times. Like I said, you should print hello 200 times. You don't want to type out hello, 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 hello. You can just use basically your loop and do that for yourself. Okay. So this range simply works like this. If I say from range 6, I'll print 0, 1, 2, 3, 4, and 5. So it starts from 0 and goes all the way to 5. So 0, 1, 2, 3, 4, and 5. It gets to 6. The way list works, it gets to 6, then it stops there, it excludes that particular number and prints everything else. That's the way it works as well. And you can also specify where you want to start from and where you want to end from. So you can say start from 1, go to 6, then jump every 4 times. Jump 4 times, okay? You're going to get start from 1, start 1, jump 2, was 1, 2, 3, 4, and print 4. Sorry, 1, then go 2, 3, 4, 5, which is 1, 2, 3, 4. So it counts 4 times, then prints the next one. So that's how we got 1 and 5. So this is just an assignment, a test. We're asked to do a for loop that goes from 1 to 100 and prints out all the odd number. When we see an odd number, if it sees an even number, it prints it out. If it sees a odd number, it says who sent you. And if it's once it gets to 100, it says who sent your papa. Okay. So when we run this and click this in, we get who sent you 2, 3, 4, and so on all the way to go to 100, which was who sent your papa. And we got 100. So you can see that for loop is one of the most amazing. It's really amazing when it comes to doing the same task over and over again. It's very fantastic to save you a whole lot. So like I said, you can specify the range and say, okay, start from a particular value, end at a particular value, excluding that value. Then you can also specify your steps like we already did. And your for loop, you can also add your else statement, which allows you to have a, like if once everything is done, give us that statement, okay? Once everything else is done, give us that statement. It's like adding an extra finishing touch, like a last word to your loops. So the only time this would not, the else statement will not print is if you add a break to your for loop. So let's run this, we get our finally finished. Then let's run this and run this. We're not going to get our finally finished because there was a break here. So everything else is ignored. Now, the way loop work in nesting, the inner loop will be executed one time for each iteration of the outer loop. Do you get it? So let's look at this example. This is our outer loop, this is our inner loop. So for each of this item here, the inner loop will be executed completely. So for red, we get red apple, red banana, red cherry. Then we'll go to big apple, big banana, big cherry. Tasty apple, tasty banana, tasty cherry. Right. So let's run it and get our answer. So we are saying for x in adjacent, for y in fruit. So we're going to print the x first, then the y. So let's run this. We get red banana, red apple, red. It's kind of like a Cartesian product of these two list items, okay? So sparse works similarly the way it works in any other scoped based data structures. It simply skips a particular, it allows us to write a particular loop and leave it there until we know what exactly the goal we want to achieve for that particular loop. So it can be used for debugging and also writing out your code before, writing out the structure of your code before actually filling in the logics and the loops that you want to actually implement. Okay, so that's all for loops. We've understood how to control the flow of our code. We've understood how to make sure that the code we want to execute is executed based on a particular condition and do a particular task over and over again until the condition is met or until a set number of times is reached. Okay. So now we can successfully create beautiful and nice codes with Python using these control flows. So I'll see you in the next video and in the next class. So bye for now, and do make sure you practice what we've done today. Bye for now.